Hey Tube, welcome back. Problem number 981, time-based key value store. So design a time-based key value store data structure that can store multiple values for the same key at different timestamps and retrieve the key's value at a certain timestamp. We need to implement the timestamp class that you can see here. First, we need to add a void, which will be a set function will stores the key with the value and the given timestamp that called timestamp. And we have a string called get string, or it's a key, an integer which will be the timestamp, and we returns a value such that set was called previously with timestamp prev should be less than or equal of timestamp. If there are multiple such values, it returns the value associated with the largest timestamp prev. If there are no value, it returns the null. Okay, what is this? Because I guess it's not that easy to understand. So let's describe the problem first, and after that, let's talk about how we can solve it. So we need to design a data structure, a timestamp map that behaves like a dictionary key value store basically, but we add another dimension which will be the time. And as you said before, it should look something like that. No, it should be look something like that, which basically store a value associated with the key at a specific time. Okay, we important construct here, set calls for the same key will always have strictly increasing timestamp. This is a crucial hint, and we need to understand that because actually this is a key that we should use a binary search data structure pattern to solve the problem. So we have the get timestamp here. This one retrieved the value for a given key at a specific timestamp. The rule for retrieval is to return the value set at the largest timestamp prev, such that timestamp prev should be less than or equal to the timestamp. If no such value exists, we return the empty string. Okay, let's make an example walking through so we can understand the problem better. So first, we will create a timestamp map. Okay, and we will create an object or a row. So timestamp foo, we have the value is bar, and the key is foo, the value is bar, the timestamp is 1. So it will look something like that, foo, and we will have bar, bar, and 1. So when we hit timestamp, we try to make a get request timestamp dot get for foo, query foo at timestamp 1. Basically, this is what we're doing. So the timestamp previous or timestamp prev should be less than or equal to 1. So what we return? We return the first one, the first object that we actually stored. So bar will be returned as a value because we search for the value. Okay, so let's make another one. We have here foo, which will be 3. So basically what we're doing, we query foo at timestamp 3, largest timestamp previous should be less than or equal to 3. So I guess we have 1, so it's less than or equal 3, so we return bar. Okay, so let's add another object. Let's set another one. So let's with different value. So different value, b bar, let's call it bar 2, and the value should be, let's make it 4. 4. And let's try to call timestamp.get, but instead of 4 with 3, let's make it 4 with 5. Okay, so we query 4 at timestamp 5, so the largest timestamp previous that is less than or equal to 5 is 4. So instead of returning this, we return 4. So we return the value of 4, which is bar 2. So yeah, this is how it works, and I hope that you understand right now how should our function behave, because this is a crucial one. So the core of this problem lies in efficient retrieval, like in the get operation. Since set operations guarantee strictly increasing timestamp for a given key, this immediately suggests that for each key, the value and their timestamp will be stored in a sorted order based on the timestamp. This sorted property is a strong hint for using binary search during the get operation. Okay, so in the data structure choice, we need to map a key to multiple value timestamp pairs. We can create a map or hash table directory. It's basically this is ideal for mapping keys to their associated data for the value associated with each key. We will store a list of array of timestamp and value pairs. Okay, how does this will work? Okay. So sorry. Okay, so we have here the function, and I guess we have two properties that we need to work with. So I guess the only thing that we need to do, we will have basically we will use a JavaScript map to store our data. The structure will be as as follows. Let's copy it because the structure will be something like that. Okay, I guess I didn't do it in the right way. Let's do it again. The structure will be something like that. What's going on? Okay, I don't know. But structure will be something like that. We will have a key string, and the key string will be an array of arrays, and each element of the array will have the first timestamp and the value, timestamp and the value, and etc. And that's it. And each array of timestamp and value pair will be stored by timestamp due to the problem's constraints on the set operation. So we create the map. This dot store. Let's call it store will equals new map. Okay, and we'll have here the time map dot get, or where's time map dot set. Oh shit, I did this mistakenly, sorry. Yeah, so we have here timestamp dot set. In this one, we will basically we store the key with the value and the timestamp. So how we'll do that? First, I will make if statement here. We'll check if the key already exists in our store. So if dot this dot store dot has the key. If it doesn't exist, if the key is new, or we create an empty array to hold its time-based value. So this dot stores dot store sorry dot set key and an empty array. Okay. After that, we retrieve the array of the timestamp value pairs associated with the key. I will do that. Const. let's call it values for this key, and it will equals this dot store dot get key. Okay, so right now we have the value. After that, we will add the new timestamp value pair to the array because the problem guarantees that set timestamp for the same key are strictly increasing. Simply, we do that by pushing to the end maintains the stored order of this array. So values here, values dot push timestamp and value. And I guess that's it. You don't need to do more. Uh-huh. And yeah, that's you don't I guess you don't need to do more at all. Oh, okay, so what next should we do? We should next work on the get property. So we returns a value that set with the set was called previously with timestamp prev, which should be less than or equal to timestamp. And if there are multiple such values, it returns the value associated with the largest timestamp prev. If there are no values, we returns null. So first we check if the key exists in our store at all. If it's not, we return no value. If it's not, basically there are no values to retrieve for this key. So if this dot store dot has has key, if the key is not live key, if it's not there, we return an empty array. Okay, so after that we need to get the array of timestamp values, if of timestamp value pair, because actually this is how we save it. As you can see here, we need to get this array of timestamp value pairs for the given key. And this array is guaranteed to be sorted by timestamp in ascending order. So let's call const historical values, which will equals this dot store dot get the key. Okay, so we will initialize the binary search pointers. So let left will equal 0 and let right will equals historical values dot length -1, and we create a results. Let result value, which will equals an empty array, and we will perform the binary search to find the floor timestamp, the largest timestamp prev, such that prev should be less than or equal to queried timestamp. So create a while loop, while left is less than or equal to right, while yeah, we will calculate mid. We calculate the middle, and mid will equal left plus math dot floor right minus left divided by 2. Okay, so we will destructure the timestamp value pair at the middle index. So const, I would say here this is the current timestamp, and we will have current value which will equal actually historical of mid. And we will check if the current timestamp is less than or equal to the queried timestamp. So if current timestamp is less than or equal the actual timestamp that we are searching for, if that was the case, this is the case one. Basically, if that was true, the current timestamp is a valid candidate. It satisfies the time stamp previous should be less than or equal the actual timestamp condition. So we store its corresponding value as a potential result. So the result value should be equals the um, the current value. Okay. Now we need to try. We try to find an even larger timestamp, which is still less than or equal the queried timestamp by searching in the right half of the current segment. So left or equals mid plus one. Okay. Else. So else this is case two. Basically, if we are here, that means the current timestamp is greater than the query timestamp. So this means the current timestamp is too recent. The desired timestamp must be on the left half of the current segment. So right will equals mm, mid minus one. And after all of that, we need to return this. So let's run. It accept everything. Let's submit. Yeah, it did work. It did work. Um, yeah. So yeah, it did work. I guess some of you will ask, how does this work? Specifically, how does this work? So basically, how we create another variable and we push it and everything went well. So we will assume this dot store is our main map object. It's initialized in the constructor. At this point, we have already checked if the key exists and created an empty, and we created an empty array for it basically if it didn't exist. Okay, so we I guess this part is quite easy and no problem with this part. I guess the trick happened here. So here we retrieve the array of the values for the given key. Okay, here we add a new timestamp pairs to that array. Okay, so one minute. So some of you will ask me how when we update this array or how when we update this element, this will be reflected in the map. So I would say this is a quite good questions, and w- we need to understand how type of objects are actually handled in TypeScript. So we have here const values for this key. So when we do that, basically what this store get key is happening returns is not a brand new copy of the array. Instead, it returns a reference of the array. Think of it as a pointer or a direct link to the exact same array that is already stored as the value for that key in your this store map or in your map. So Imagine your this store map is like a big cabinet, and each drawer, which is a key, has a label inside that drawer. Okay, there is a piece of paper which is the value. So when you store the array in the map, what's on the paper is not the entire array itself, but rather the location, which is memory address of that array in your computer's memory. So when you retrieve it with this .get .key, so the values for this key, because becomes basically a new label that also points to the exact same array in memory. So how this actually reflects in the map. So because values for this key, this variable, is a reference to the original array, any operation that modifies the array in place will directly affect that the array that is in the map. That basically, sorry, it will reflect in place. It will reflect directly the array, or affect directly the array that the map is holding. Okay, so yeah, that's it for this video, and thank you for watching it.